Hello everyone. So the driving question for chapter 1.1 is how do I apply systematic listening strategies including use of the product rule for counting. Okay, so we're looking at different number problems and reasoning, and in this particular session we're going to be looking at the outcomes of an event. Okay, this is something you should have seen before in year 9, but it is something we're going to go over. Okay, I'm going to start with a modelling activity. So I just want you to watch me go through these two questions, and then you'll have a chance to have a practice, and we'll progress through like that, okay? So just bear with me as I set up the visualizer, and then we will get started with the example that's on the screen. Have a look as I'm setting it up as to what you think the outcomes for each of the different events would be. Okay, so the first question I've got there says each spinner is spun once, list all the possible outcomes. Okay, so my first spinner, this one over here, the two outcomes I have is R or B. In my second spinner, the two outcomes I have is W and G. So if I were to list all my possible outcomes, if I spin the first one, my outcome, I could get R. And then when I spun the second spinner, I could get W. Or if I got R, I could also have got G on the next spinner when I spun that. Okay, and then I could have also had B in the first spinner, and therefore W in the second, or B on the first spinner and G on the second. Okay, it's all the possible outcomes if I spun those spinners. What could I get when I did that? Okay. On the second one, it's got each spinner is spun once, list all the possible outcomes. Now, I've got 3 options now on my first spinner and 2 on my second. So I know with each of my possible outcomes on the first spinner, there's 2 outcomes on the second. So with C, I'm going to have 2 possible outcomes. It's either going to be C and 1 or C and 2. And that goes the same with the other letters. It's either going to be B and 1 or B and 2, or it's going to be A and 1 and A and 2. Okay, and they're all my possible outcomes there. Okay, so pause the screen then please and have a go at listing all the possible outcomes on the 2 questions that you've been given. Be careful on B4. Think about how the fact that there are 2 number 2s on spinner 1 and 2 letter R's on spinner 2. Think about how that's going to affect your outcomes. Okay, so pause the video, have a go, and then I'll go through the solution with you. Okay, so let's have a look then at the solution for your try activity. So, each spinner is spun once, list the possible outcomes. Okay, you've got 3 options on your first spinner, 3 options on your second. Therefore, if I started with the number 5, there's 3 possible numbers that could go with that number 5. So I've got 3 outcomes with 5. It's either going to be 5 and 6, 5 and 2, or 5 and 4. And the same goes with the other numbers. It's either going to be 1 and 6, 1 and 2, 1 and 4, or 3 and 6, 3 and 2, 3 and 4. And they're your possible outcomes for B3. Now B4, this is the one I told you to think about carefully. Each spinner is spun once, list all my possible outcomes. So there's 4 different outcomes on spinner 1. However, 2 of them are the same. Okay, so I can't write 2 in there twice with each of the different outcomes from the next spinner. It's only going to land on 2 once, okay? It's going to be either of the 2s, but 2 doesn't change. It will still be 2. So it's either going to be 1 and B or 1 and R, because once again, on the second spinner, there are 2 R's. So I wouldn't write 1 and R twice because it's the same outcome. Okay, so it's 1 and B, 1 and R, or it's going to be 2 and B, 2 and R. That's if it were to land on a 2. Remember, there's two times that it could land on a 2 on the first spinner, and then B and R, and then finally 3 and B, 3 and R. Okay, so we shouldn't be repeating the 2's and we shouldn't be repeating the R's, okay, because it's the same outcome. Okay, so you've got a warm-up activity now. I wanted to give you those 2 examples just as a quick refresher. So if you could please have a go at the questions on the screen, pause the video and play when you're ready to go through the solutions, and think about what we've just gone over in those 2 examples to start us off, okay? So pause and play when you're ready for the solution. Okay, so let's go through the solutions here. So for question 1, it said, copy and complete this list of all the possible outcomes of rolling a dice and flipping a coin, okay? So first, if you think about when you roll a dice, what are all your possible outcomes? Well, I can either get 1, 2, 3, 4, 5, or 6. And when you flip a coin, what are your outcomes? Well, it's heads or tails, okay? So it wants us now to write all the possible outcomes of rolling a dice and flipping a coin. So I'm either going to get heads and any one of those numbers. It's either going to be a heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, or I'm going to get tails in all of those numbers. Okay, so tails and 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Okay, then part B said how many outcomes altogether? Well, there's 6 and 6, so there's 12 outcomes. Question 2 says copy and complete the list of possible outcomes for spinner A and spinner B. Okay, so they've started you off. You can have either 2 and all of the options on spinner B, 4 and all of the options on spinner B, or 6 and all of the options on spinner B. Okay, so I'm going to go 2 and 1, 2 and 3, 2 and 5, 2 and 7, 2 and 9. Or we can have all of those options on spinner B again, but with 4 instead. So 4 and 1, 4 and 3, 4 and 5, 4 and 7, 4 and 9. Or we can have all of those options again, but with 6 on the first spinner. So 6 and 1, 6 and 3, 6 and 5, 6 and 7, 6 and 9. Okay, they're all my possible outcomes. It then says for part B, how many outcomes are there altogether? Okay, well there's 5 in each list. Okay, there's 5 possible outcomes in each of these lists, so there's 15 outcomes altogether. Okay? Sorry, that's gone slightly off the page. So then for question 3, it says, it's just breaking down what you've done previously, okay? So 3A says, how many possible outcomes when you're flipping a coin? Well, we discussed that. It's heads or tails, so there's 2. Heads or tails. Sorry, that's rolling the dice, the first one. So there's 6. We discussed that up there. 1, 2, 3, 4, 5, or 6. Okay? B has asked you for flipping a coin, and as we've said, there's 2 options for flipping a coin, heads or tails. C says how many possible outcomes for spinning A. So that's with the little spinner that we use in A. Well, there are 3 possible outcomes, either 2, 4, or 6. And D wants to know about spinner B in question 2, and there's 5 different options, 1, 3, 5, 7, or 9. So 5 different outcomes. Okay? Then it asked you, it said to have a discussion, but obviously you couldn't have a discussion, you needed just to have a think. What do you notice about your answer to part I? Says question 1B and 3A and B above. So question 1B, we said there were 12 outcomes, and 3A and B, we said, well, there's 6 outcomes for rolling a dice and 2 outcomes for heads or tails. And the relationship is, if I multiply the number of outcomes for rolling a dice and the number of outcomes for flipping a coin, I get the total number of outcomes when I'm flipping a coin and rolling a dice. Okay? And that's the same for part 2. I want you to consider the relationship between your answer for question 2B with the 15 outcomes, and then for C, the number of outcomes in spinner A, and D, the number of outcomes in spinner B. Okay, and it's the same thing. If I multiply those two number of outcomes together, 3 times 5, it gives me the total number of outcomes if I was spinning both spinner A and B together. Okay, so I multiply them together. Okay, have a go at question 4 then, please. So pause the video and play when you're ready to go through the solution. It's very similar to what we've just been doing. Okay, let's go through the solution then. Okay, I'm going to put the answers on the screen as well, and then I'm going to go through them with you. So, 4 says, a restaurant offers a set menu for birthday parties. Write down all of the possible combinations of starters and main courses. Okay, so you've got the list of starters there. It's either vegetable soup, salad or melon, and then the list of mains is pizza, spaghetti bolognese, curry or lasagna. So I'm going to write down all my possible combinations. Well, I could have vegetable soup, which I'm going to call V, and pizza. I could have vegetable soup and spaghetti bolognese, which I'm going to call B, as I've suggested. I could have vegetable soup and curry, or I could have vegetable soup and lasagna. Okay, so they're all my options for vegetable soup as a starter. If I had salad as a starter, I could have salad and pizza, salad and bolognese, salad and curry, or salad and lasagna. Or if I had melon as a starter, I could have melon and pizza, melon and bolognese, melon and curry, or melon and lasagna. Okay, they're all my options there. All the different possible combinations. So then it says, how did you order your list to make sure you didn't miss any starters or mains? Okay, so for me, I just wrote out all of my starters with each of the different main options first. Okay, and I ordered it with writing the vegetable soups first, then the salad, then the melon. Okay. Question B. Oh no, that's what we've just done, sorry, apologies. Question C. How many possible combinations are there now? So it says the restaurant decided to offer fish as a main course. How many possible combinations are there now? Okay, so what you have to think is, well, fish is another main course. So each of those starters, if I go back to my part 1, each of those starters is now going to have a fish option, isn't it? So there's an extra 3 different options. There'll be 15 outcomes altogether. Okay, and remember the other way you could have done that is, well, there's 3 starter options, and now there's 5 different options for the mains. Multiply them together, that gives you your 15 outcomes or combinations. Okay. Part D says copy and complete. Okay, so if I have 3 starters and 4 mains, how many combinations can I have? Well, I'm going to have 3 times 4, so 12 combinations. Okay? For 3 starters and 5 mains, we've just done that. It's 3 times 5, so that's 15 combinations. And then it's got n starters, so an unknown number of starters. Remember this, bringing algebra in now. So n starters and m mains. Okay, so we don't know those numbers. Well, we just times them, don't we? N times M, which equals NM. Okay, NM. So it's whatever the number of starters, if we times it by the number of mains, that's going to be the number of combinations we can have. It then says a different restaurant offers 2 starters, 4 mains and 3 desserts. How many possible combinations now? So we have 2 starter options, 4 mains and 3 desserts. Okay, 2 times 4 is 8, 8 times 3 is 24. Okay, so that's combinations. Okay, well done if you got those. Okay, so now I'm going to go through this question with you as an example. It's an exam style question and you can use a calculator. So please have a calculator or your phones ready so you can use them as I'm going through with you, okay? So the key point says where there are n ways of doing one task and n ways of doing the second task, the total number of ways of doing the first task, then the second task is m times n, okay? So that's what we've already discussed. It's m times n. So let's have a look at the question. The question says, Jess has a 4-digit password for her mobile phone. Each digit can be between 0 and 9 inclusive. That means it can be 0 as well. Okay, so 0 and 9 can both be part of the combination. How many choices are possible for this 10-digit code? So what numbers can she have in this 10-digit code? Well, she could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. They're all the different possible combinations that she could have, okay? Oh, not 10, sorry, and 9. So how many are there? Well, that's 10 different choices for each code, okay? They don't want to know the total possible outcomes for her 4-digit password. They just want to know how many different options can she have for each number, each digit of the code. So there's 10 possible choices, okay? I'll put choices there. Okay, part B says, what is the total number of 4-digit passwords that Jess can create? Okay, so we need to know what the number of outcomes are for the 4-digit password. Okay, so she's going to have 1 digit, 2 digits, 3 digits, and 4 digits. There's 4 digits to her passcode, and each one has 10 options. It can be 10 different numbers for each number in the code. So as we said before, we're just going to multiply them all together, and that's going to tell us how many different possible combinations she can have. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So she's got 10,000 different options for her code, depending on what she picks. Okay? Then part C says, Jess would like to choose an even number. The code can start with a 0. How many different ways are possible now? So we need to consider something. So we've got 4 different digits, first digit, second digit, third digit, 4 digit. She wants it to be even. So in order for a number to be even, it must end in an even number. Now, in the list of numbers that she can have, in the different digits that she can have, there are 5 even numbers. So the last option, she only has 5 choices of numbers, okay? It's either going to be 0, 2, 4, 6, or 8. The other numbers, they can still be any of the different digits, okay? So she has 10 choices for the other 3 digits. So now you've worked out that, we multiply them together. 10 times 10 is 100, times 10 is 1,000, times 5 is 5,000. So she has 5,000 different combinations or options, okay? Okay, so now, question 6. I'm going to read through it with you, give you any hints if I think that you need them along the way, and then you need to pause the video, please, and have a go and play when you're ready for the solution. So you can use a calculator as well, okay? And in fact, you will need a calculator because it's tricky sums. Okay, so question 6 says 3 people, A, B, and C, enter a race. Write down the different orders in which they can finish first, second, and third. Okay, so think about what we've just done. There's 3 different places. How many people can finish first? Therefore, if somebody has to finish first, how many then can finish second? And then if we've got people in first and second place, how many people are going to finish third? Okay, how many possible outcomes are there? Then multiply them together. Harry says that there are 3 possible winners, but then only 2 possibilities for second place and only 1 for third place. Okay, is he correct? And that's also going to help you with that part A. Is he correct there in thinking that? Part B. How many different ways can people finish in 1A, a 4-person race, 2, a 6-person race, or 3, a 10-person race? Okay, and consider what you've thought for your answer to part A and for what Harry has said in his discussion. Think about how many people are going to be able to finish in each of the places. Okay, and then you've got a communication hint. A factorial is a result of multiplying a sequence of descending integers. For example, 4 factorial is written as 4 with an exclamation mark, is the same as 4 times 3 times 2 times 1. Make sure you know how to use the factorial button on the calculator. Okay, so it's the button that they're showing on the screen. If you don't have that because you're using the phone, just write it out the long way, so 4 times 3 times 2 times 1 on your phone. Okay, so pause the video and play when you're ready for the solution, please. Okay, so the answers are there on the screen. I'm now going to go through the solution with you on the visualizer as well, just to explain. Oh, I think I got rid of the part of the discussion, but that's fine on this part. So, question 6. 3 people, A, B, and C, enter a race. Write down the different orders in which they can finish. Okay, first, second, and third. So the orders were going to be, you can have person A is first place, with then B in second, C in third. I'm actually going to write first, second, and third there, even though that's not part of the combinations. Or you could have A, then C, then B. Or you could have B, then A, then C. Or you can have B, then C, then A. Or you could have C, A, B, or C, B, A. Okay, they're your options. Then the bit that's missing on that screen says, Harry says that there are 3 possible winners, but then only 2 possibilities for second place and only 1 left for third place. Is he correct? Well, I've got first place, second place, and third place. He is correct because there's 3 people that could possibly finish in first place. As somebody has to finish in first place, there's therefore 2 people only that can finish in second place, and therefore only 1 person that can finish in third place. Okay? There's not 3 different options each time. So if I carried on doing what I was using before, and I did 3 times 2 times 1, it would tell me the number of possible outcomes is 3 times 2, which is 6 times 1. So there's 6 possible outcomes. Is that right? Let's look. 1, 2, 3, 4, 5, 6. Yes. So Harry is correct. Okay? Carrying on, part B said, how many different ways can people finish in a 4-person race? Well, if there's 4 places, you can either finish first, second, third, or fourth. Rather than writing out all the different combinations, it's going to be like what we've just discussed. So 4 people can finish first, but somebody has to finish first. Therefore, only 3 people can finish second. And as somebody has to finish first and second, there's only 2 people that could finish third. And as 2 people had to finish third, there's only 1 person that can finish fourth. So to find the answer here, we had to do 4 times 3 times 2 times 1, or remember 4 factorial. You could put that in your calculator as well, and you would have got 24. Okay, that's 24 ways. And then question B2, it's in a 6-person race. That was one. In a 6-person race, again, we've got 6 different places: first, second, third, fourth, fifth, and sixth. Somebody has to finish first. That can be any of the 6, then 5, then 4, then 3, then 2, then 1. So multiply them together, or your 6 factorial, and you would get 720. Okay, so that's 720 ways that they could finish. Okay? And then finally, part 3, question B, part 3. In a 10-person race, again, you don't need to write this out each time, it's just so it makes sense. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. You can have 10 people, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, or 10 factorial. Multiply them together, and you would get 3,628,800 ways. Okay? They're all the different combinations that each person could finish in a 10-person race. It's a lot of ways, isn't it? Okay, oh, sorry. Okay, carrying on then, have a go at question 7, please. I'll just put it on the bigger screen for you, and you can use a calculator. Again, you'll need a calculator because the numbers get rather big. Pause and play when you're ready for the solution. And just to clarify as well, do this assuming that the code can be, again, from 0 to 9. Each digit can be from 0 to 9, like in the previous question that we did. Okay, so let's go through the solution then. The answers will be on the screen, and I'm going to go through it as well there for you. So, Eddie needs to choose a 6-digit code for his computer password. How many codes can Eddie create using 6 numbers? Okay, so 7A part 1, they want to know how many can he create using 6 numbers. So it's 1, 2, 3, 4, 5, 6 different digits. And each one, for each digit, he has got 10 options, okay? Because remember I said from 0 to 9, there's 10 different options that he can have for each number in his code. So there's 10 options there, and it doesn't change. It doesn't say that he can't have the same number. So each time there's 10 options. So 10 times 10 times 10 times 10 times 10 times 10, or 10 to the power of 6, which is 1 million. Okay, so there's 1 million different combinations he could have there. Okay, how many codes can Eddie create using, this time he's got 4 numbers and 2 letters. So there's 4 different possible numbers: first number, second number, third number, and fourth number, and then 2 letters. So letter 1 and letter 2. So that is what he needs. How many combinations for each? Well, he can have 10 for each number, because again, it doesn't say they can't be repeated. So he's got 10 different options for each of the numbers, and 26 different options for each of the letters, because there's 26 letters in the alphabet. Okay, so you need to do 10 times 10 times 10 times 10 times 26 times 26, and that gives you 6,760,000. Okay? Then part I, part 3. One number followed by 5 letters. So we've got one number followed by 5 letters. So letter 1, letter 2, letter 3, letter 4, letter 5. Okay? So he's got 10 options for his numbers and 26 options for each of his letters. So you need to do 10 times 26 times 26 times 26 times 26 times 26. And that will give you hold on, 118,813,760. There we go. That's how many different codes he can make there. Okay, so part B then says, Eddie decides that he does not want to repeat a digit or a letter. So how many ways are possible in parts 1 to 3 now? Okay, so now he doesn't want to repeat any of the digits or letters. So for part BI or B1, he wanted 6 numbers in his code. So there's 1, 2, 3, 4, 5, 6. So 6 different digits that he can have, but none of them can be repeated. So for the first digit, he's got 10 options. Then for the second, just 9. Then third, 8. Fourth, 7. Fifth, 6. And sixth, 5 options. Okay, so you need to multiply each of those together to find out how many different ways he can have his code for that. And that would be 151,200. Okay, because it's descended each time because he can't repeat a digit. So for part 2, he wanted 4 numbers, so 1, 2, 3, 4, followed by 2 letters. So he's got letter 1 and letter 2. Okay, so he would have 10 options for number 1 for the first number that he picks, 9 for his second digit, 8 for his third, and 7 for his fourth. He has 26 options for letter 1, and then only 25 options for letter 2. Multiply each of those together, and you will get 3,276,000. Okay, which is because each of them descend. Okay, and then for part 3, he's got one number followed by 5 letters. Okay, so he's got 10 options for whatever the digit is that he picks. Then for the first letter he has 26, and then it's going to descend, then 25, then 24, then 23, then 22, because he can't repeat the letter. So whatever he's picked in the numbers before, he has that many fewer options for his last letter. Okay, and if you multiply each of those together, you will get 78,936,000. Okay, which is a lot of ways. Okay, so that's the end of this session. Well done. Please go back through if there's anything that you didn't understand or that you need to practice again. And then you'll be ready for the next stage of the lesson, okay, for point 2. But it's slightly different what we're doing then anyway, but please make sure you do have a good understanding of what we've done here. Okay, thank you very much.